Hello everyone, today we are going to make a MPU6050 3D sensor visualizer. This is an extension of my previous video where I created a live dashboard of MPU6050. In this video, you can see we used the 3D visualization with 3D 3.js file, and we used a simulated real-time data with Flask, HTMx, and Three.js. Here you can see a simulated values. You may notice the difference. We are not going to get a raw data of the accelerometer. Either we are going to fetch the pitch, roll, and yaw. So these values will give us the actual orientation like this, and you can zoom in, zoom out, or play with the plane as you wish. So that's a basic of simulated environment. Then we are going to switch this to the actual sensor value. This is an update code for fetching the yaw, pitch, and roll. So we are going to use this library for actual computation. We create an instance of MPU6050. After that, we need to calibrate that. So the MPU6050, we call the function calculate gyro offsets, and these offsets will be used for the calibration purpose. And when you are going to calibrate the sensor, you have to still the sensor and do not move that. After that, we just call the update function, and all the sensor fusion algorithms will be running inside this library, and you will get the gravitational constants ax, ay, and az, and then you will get the yaw, pitch, and roll from the angles. Z angle is often used for roll, so that's how you will fetch the reading, and you will print that reading to the serial port. So if we go to the port section and we open up the port, you will see the readings like calibration sensor, and do not move that. And here are our offsets values, and then you will continuously fetch this data. So my sensor is still and is not moving, but still you are able to see a lot of variation in this. So that's the noise in our MPU6050. So let's close this and remember this port number, which is port 13. And let's go back to our Arduino Python code where we created a Flask server. And inside that, we are going to use it. Let's close the previous running code, and this is the new code. Here you need to change the port number, and baud rate is 115200, and the reading process is pretty similar like our previous code. If you have not watched the previous video, I will put a link in the description. You can go and watch that. The serial process reading is pretty simple. We created a global sensor data instance, and this is our dictionary, which is used with the threading lock so that the race condition is not occurring. And inside this thread, we are reading a line, and we are stripping the values. Then we are splitting by comma separated list, and with the data lock, we are filling the dictionary with the proper values. And the route is index 4. And if we go inside this index 4, here you will see all of our code. So we are importing the libraries for Three.js, and we are also using add-ons. And inside that, we are just creating simple CSS for our background and data cards. Then we are importing some fonts from Google Font, and inside that we are simply creating some divs to display over Three.js values. So here you will see sensor readings, and inside that you will see the values for the sensor data. And if you come down and for the Three.js, you will see object of orbit controls, and you will initialize the scene from Three.js file, and you set a background color. Then you will instantiate a camera. So this is a basic 3D setup, and the perspective of the camera, you put these values. So that will, you have to position this camera, and you position to some axis for initial default, and then you render this scene. You can set the size and pixel ratio, and you simply append the child on the canvas. Then you add a scene. You put an ambient light and directional light. So light will light up your scene, and then some geometrical boxes for your accelerometer, and you will put some lines to indicate the direction. And finally, you will call the animate function. The animate function will request the animation frame, and controls will be updated, and the scene is rendered with the scene and the camera. When the window is resized, you will handle the resize, and that's all you need to do for the Three.js setup. And for all the event, you will call the HTMx after onload, and inside that you will parse the JSON data, which is fetched from the backend of the Flask, and then you will put a pitch, roll, and yaw, and then you will set the rotation of the cube according to the pitch, yaw, and roll. Then you will position it and rotate the cube accordingly. And here is a pretty simple data display inner HTML, which will display the sensor values. So that's how the sensor value is fetched from the backend and displays on the front end. So let's run this by Python app4.py, and now our server is running, and here you can see the calibration process is being done, and once the calibration is done, now your program is correctly able to run. So when you load this value, here you will see the same process and the orientation, and here you will see the live value of the sensor. If I move the sensor, you will see the 3D object moving accordingly. And once if the wiring is loosed, um, okay, so here you will see a lot of noise coming on, but yeah, as I move my sensor, our 3D object is moving accordingly. And if I flip the orientation, it flips as well. So as you are seeing, there are a lot of jitters. These are for the noise, and we will leave to add some filtration process in our sensor for upcoming video. So that's all for today's video, and don't forget to subscribe if you want to see more what I do with this sensor.